In experimental fire research, some of the most compelling data that you can get is the visual data from video and photography. So we're always looking for ways to get closer to the fire and to see into compartments when they're burning. And we had heard that some people had had some success simply putting cameras into water, and so that was kind of the starting point for our idea, and we took that and we started to iterate on that. The first time we tried this, we found that the water started to boil really quickly, so we had to solve that problem. And we also learned pretty quickly that you need to minimize temperature variations in the container which you put the water in, because otherwise the container can break. All right, so the first step of setting this up is figure out where you want to place your camera, and that's where you're going to put your beaker, which you see here. This could be any glass container. We've been using Pyrex, which is not as sensitive to the thermal shock, so you definitely want to use a high temperature glass there. You see on the top of this beaker here, we've got this little plate of metal, and that's been secured with high temperature silicone. This is in there simply so that when we fill this up with water and it flows out the back here, that we don't get any drips running down the front of the beaker and getting in our field of view. We observed that as the temperature of the water goes up, the life of the battery goes down. So you have to figure out how long you're going to be running your test and either keep the temperature of the water down or figure out a way to swap the battery out. All right, so we've got the beaker secured in place, and now we're going to hook up the water recirculation line. Basically what you're seeing here is we've just taken a 3/4 to a 3/8 inch step down. This is an off-the-shelf shielded thermocouple with a plug on the end of it. So this is sensing temperature down at the end of this probe, which is just in the flow line here. And we do this just to monitor the water temperature. All right, so what we're going to do now is we're hooking up the water inflow line. Again, you can set this up any way you want. We've just taken some copper tubing. I think it's 3/8 inch copper tubing, and we put a little gooseneck on here, which is going to go down to the bottom. And we've hooked this up to our hose cold water inside supply on the back of the compartment here. We've got the container filled with water. You can see it's flowing out the back side here. Front side is staying dry. So on the camera, we've just taken this camera and the mount that comes with the camera, and we've just clipped it onto a steel block or a piece of steel channel just to give it a little extra weight so it's not moving around in there. And we'll leave a little window open right where the camera's going through. So this keeps the steel pan from heating up where it's not water cooled, and it also keeps the amount of radiation getting to the camera and to the water here, which is going to cause the water to heat faster to the minimal possible amount. You can use a cell phone, or you can just, if you can communicate with your camera, or you just turn it on before you put it in there, get the right field of view, and you're good to go. In case things don't go as planned when you're doing this, it's always good to have a backup. For example, we would attach a cable to the equipment, the video equipment that we were using, and run it out away from the fire. So if the container broke or if the temperature of the water got too hot, which we were simply measuring with a thermometer, that we could then pull the equipment out of danger from a safe distance. I want to remind everybody that when we're doing these experiments, we're doing them in a controlled facility. We have the fire department supporting us, and the people who are doing this are trained to get close to fires and are wearing personal protective equipment that allows them to go in and take this kind of imaging. So we'd never recommend that somebody try to do this on their own.